Hi, in this lesson, we're going to use linear equations to solve word problems. And there'll be three types. First type is called a cost mixture word problem. The formula that we'll use there is amount times cost equals value. The second type are called percent mixture word problems. That's amount times percent equals quantity. And the third type are called uniform motion word problems. That is rate times time equals distance. So let's start with the cost mixture word problems. So with cost mixture word problems, we'll be mixing ingredients to come up with a new mixed ingredient, such as mixed nuts or different blends of coffee. So let's start with the first example. How many pounds of substance A, which costs $2 per pound, must be mixed with 18 pounds of substance B, which costs $2.40 per pound, to create a mixture which costs $2.08 per pound? Remember, the formula is amount times cost is value. So we use a chart in order to keep ourselves organized. In the first column, we put the ingredients. So we have substance A and substance B, and those get combined together to create a mixture. So amount. We don't know how much we have of substance A. In fact, that's the question. How many pounds of substance A? That's our variable. But we know that it costs $2 per pound. So that goes into your cost column. And then let's move on to substance B. You're told that there are 18 pounds of substance B and it costs $2.40 a pound. So that's what you see in the second row. And then your mixture, well, remember, you're combining substance A and B, so the amount is X plus 18, and you're told that it costs $2.08 per pound. All right, so in the last column, the value column, it's just the product of amount times cost. So that's what you see in this column. The value for substance A is 2x. The value for substance B is 18 times 240. The value for the mixture is $2.08 times x plus 18. So if you organize your chart correctly, you basically have your linear equation right here. Our linear equation is the last column, the value column. So that's what you see here. 2x plus 18 times $2.40 equals $2.08 times x plus 18. In other words, the value of substance A plus the value of substance B equals the value of the mixed product. All right, so now it's just a matter of solving for x. So remember, to solve for x, you need to get your x's on the same side. So first thing I did was distribute $2.08 across on the right to get $2.08 x plus 37.44, and here I also multiplied 18 and 240. That gave us 43.2. Okay, so now I need to get my x's on the same side, so I decided to move the 2x over to the right, so subtract 2x from both sides. So when you simplify, the 2x's will cancel, and you have 43.2 equals 0.08x plus 37.44. Now to isolate my x term, subtract 37.44 from both sides. So when you do the subtraction, you get this result here in this line, 5.76 equals 0.08x, divide by 0.08, and you get that x is equal to 72. Remember, x is the number of pounds of substance A, so you have answered the question. You have 72 of substance A. Okay, let's go on to another example of cost mixture. Here we have 45 pounds of coffee costing $9 per pound, and it is mixed with 30 pounds of coffee costing $5 per pound. And how should the mixture be priced? So we want to know the cost of the mixed product. So again, here are our ingredients, coffee 1 and coffee 2, creating this mixture. Our amounts are given, 45 pounds as well as the cost. So we have 45 times 9. And second coffee, we have 30 pounds of that costing $5. So that's the second row for coffee 2, your value is the product of the amount and the cost. So first, coffee A is 9 times 45. Coffee 1 is 9 times 45. Coffee 2 is 5 times 30. And the mixture's value is 75 times X. Where did 75 come from? Well, it's just the sum of the two amounts of coffee 1 and 2 because they're being combined together to create a new brand of coffee. So again, if you do this right, your equation should be the last column. So that's exactly what you see here. 9 times 45 plus 5 times 30 equals 75x. So multiply the 9 and the 45 as well as the 5 and the 30, and you get the numbers here on the second line. 405 plus 150 equals 75x. Add 405 and 150, you get 555. Divide by 75 in order to isolate for x. Remember, you're solving for a price, so you want to make sure you present your answer in dollars and cents. So you want 2 decimal points. So your answer here is $7.40 per pound for the new product of coffee. Okay, let's move on to percent mixture problems. These are similar to cost mixture, except instead of a price or a cost, a dollar amount, we're going to be dealing with a percentage. So you'll be mixing ingredients with certain percentage of a material to create a new ingredient, a new mixture. All right, so here's our first example. A pharmacist dilutes 18 liters of an 8% solution with a 4.5% solution to make a 6% solution. How many liters of the 4.5% solution are added? All right, so I'm calling my ingredients solution 1 and solution 2, and we're creating a mixture. All right, so you're given that the first one has 18 liters of 8% solution. So with percentages, you can't write 8% in the percent column. So instead of writing 8%, I put 0.08. You want to convert it to a decimal by moving the decimal point 2 positions to the left. And the amount goes in the first column, that's your 18. And that gets combined with a 4.5% solution, but you don't know how much of that there is. It's not given. So in the second row here, you write that you have X amount. The percentage is written as 0.045. And you're creating a new mixture that will have an amount of 18 plus X. So again, add the 18 and the X. And you're told that it has a 6% concentration. All right, so last column, the quantity column, is the product of the amount and the rate. So the first one is 0.08 times 18. Second one is 0.045 times X. And the third one is 0.06 times 18 plus X. Okay, last column is our equation. So that's what you see here. It's basically the quantity of solution 1 plus the quantity of solution 2 equals the quantity of the mixture. Now it's just a matter of getting X on the same side of the equation and solving for X. So second column, all we did was multiply the 0.08 and the 18. That gave us 1.44. And we also distributed the 0.06 across that parentheses. All right, then I decided to move my X's over to the right. So I subtracted 0.045 from both sides to get this line right here. So I have 1.44 equals 1.08 plus 0.015x. All right, so now I need to move the 1.08 over to the left. So subtract 1.08. We get this line. 0.036 equals 0.015x. Divide by 0.015, and we get that x is equal to 24. Remember, x is an amount in liters, so you need 24 liters of solution 2 to create a 6% mixture. All right, next example. We have 50 liters of a 30% concentrate, and it's mixed with 30 liters of a 40% concentrate to form a new concentrate. What is the strength or the concentration of the new concentrate? Okay, so we're going to be solving for the percentage of the mixed product. So again, we have two ingredients. I'll call it concentrate 1 and concentrate 2 to create a mixture. The amounts and the percentages are given for both concentrate 1 and 2. I have 50 liters, 30%. That's your first row. I have 30 liters, 40% concentrate. That's your second row. Again, remember to convert percentages to decimals. The last column is the product of the first two. So amount times rate is your quantity. And again, the last column is your equation. So that takes us to the first line of our equation, which is right here. 50 times 0.30 plus 30 times 0.40 equals 80 times x. So do the multiplication on the left. That'll give you 15 plus 12 equals 80x. When you add 15 and 12, you get 27 equals 80x. Divide by 80. When you convert that to a decimal, it's 0.3375. But remember, that's just the decimal. You want to express it as a percentage. How do you convert a decimal to a percent? Well, all you do is multiply it by 100, and we get the result of 33.75%. So the strength of the new concentrate or the mixture that is created is 33.75% concentrated. Okay, here's another percent mixture problem. It says a clothing manufacturer has some pure silk thread and some thread that is 75% silk. How many kilograms of each must be woven together to make 75 kilograms of cloth that is 90% silk? Okay, so this time you're not given the amount of your ingredients. Your ingredients are pure silk and some other type of thread or silk thread that's being combined with it to create another silk thread that isn't quite as pure. Okay, but since you don't know the amounts of the ingredients, but you do know how much you want of this new silk thread. You want to make 75 kilograms that is 90% silk. So if you populate that last row right away, that will allow you to express your amounts in terms of 75. You don't know the amounts of pure silk or the silk thread. So you need to assign a variable to either one of the two. It doesn't matter which one. I let x equal the silk thread, the one that isn't pure. So therefore, the pure silk must be the total minus this amount. So the pure silk has an amount of 75 minus x. So now that you have established your amounts, you can now use your percentages. Notice that pure silk means that there is no other ingredient in that thread other than silk. So that percentage is 100%. So how do you convert 100% to a decimal? Well, that has a rate of 1. Then the other thread is 75%. So that's 0.75. And remember, you wanted to create a 90% silk thread. So that's 0.90. The last column, the quantity, is just the product of the first two. So you get 75 minus x in the first column, 0.75x in the second, and then 0.90 times 75. Last column is your equation. So that's what we have written here. So the quantity of pure silk plus the quantity of the silk thread gives you your new mixed silk thread. All right, so here, minus x and 0.75 combine to give you minus 0.25. So that's on your second line. And then 0.90 times 75 gives you 67.5. Then you need to get your x alone on one side and your constant on the other. Subtract 75 from both sides. You get negative 0.25 equals negative 7.5. Divide by negative 0.25, and you get that x is equal to 30. Remember, 30 is the amount of the pure silk, and then 75 minus x is the amount of the, 30 is the amount of the silk thread, and the 75 minus x is the amount of the pure silk. So we get 35 and 45 as your answers. Okay, so that's it for mixture problems. Both cost mixture and percent mixture problems are similar. Just make sure that when you're dealing with percents that you convert your percentage to a decimal. All right, so let's move on to uniform motion. So uniform motion says 2 runners begin jogging in opposite directions from the same point at the same time. One runner jogs 1 mile per hour faster than the other. If in half an hour the joggers are 6 miles apart, then how fast was each jogging? So here, these are not mixture problems, so you really only need to indicate the objects that are moving. So for us, it will be jogger 1 and jogger 2. The formula that we're using is rate times time equals distance, which is what you see here. Rate will be a speed. Time is obviously going to be minutes or hours. And then the product of the two, rate times time, will give you the distance traveled by the object, in this case, the jogger. All right, so we don't know how fast each jogger is running. That's what we're trying to find out. How fast is each jogging? But we do know that there's a relationship between the two. We know that one jogger runs or jogs 1 mile per hour faster than the other. Okay, so how do we express one in terms of the other? You assign a variable to one of them. So I'm going to let jogger 1 be R. And so jogger 2 will be the faster runner. So if jogger 1 has a rate of R, jogger 2 is 1 mile per hour faster. So he or she is R plus 1. Remember, they're running for half an hour. So that's why I have 1/2 in the time column. So don't convert that to minutes. Right? Our speed is in terms of miles per hour. So you want to express your time in terms of hours, 1/2 of an hour. And then your distance is rate times time. So it's 1/2 R, and then 1/2 times R plus 1. So with these problems, you have to be a little bit more careful. Your last column isn't always your equation. You have to think about what they're doing. So this piece of information is important. It says that in half an hour, the joggers are 6 miles apart. So that means that the total distance between them is 6 miles. And remember, 1/2 R is the distance of jogger 1, 1/2 R plus 1 is the distance of jogger 2. So your equation is the sum of their two distances equals 6. So now we just have to solve for R. All right, so there's more than one way to solve this equation. So I decided to get rid of the fraction. So in order to get rid of those 1/2s on the left, I'm going to multiply both sides by 2, which is what I did here. When you distribute the 2 and the 1/2 will cancel, which leaves you with this equation. So you have R plus R plus 1 equals 12. Then we just have to combine like terms on the left. So R plus R gives you 2R plus 1. Subtract 1 from both sides, you get 2R equals 11. Divided by 2, you get R is 11/2 or 5.5. So what does that mean? Remember, R is the speed of jogger 1. So jogger 1 is traveling at 5.5 miles per hour, and jogger 2 is 1 mile per hour faster. So add 1 to 5.5. And he's jogging at 6.5 miles per hour. All right, so here's another one. A car begins heading along a path at 50 miles per hour. A second car begins an hour later along the same path, traveling at 70 miles per hour. For how long will the first car have traveled when the second car overtakes it? All right, so initially you see that you're given speeds or rates for both car 1 and car 2. So those are our descriptors, car 1 and car 2. Here's our rate, 50 miles per hour and 70 miles per hour. You do not know the time for these two cars or how long they've been traveling, but you do know that the second car begins an hour later than the first car. So if the first car is traveling for T hours and the second car started an hour later, that means he's been traveling 1 hour less, then the second car's time is T minus 1. Now, distance, that's the product of rate and time. So I get 50 times T and 70 times T minus 1. So now the question is, what is the equation? It's different than my first example. I don't know how far apart they are because basically they're going in the same direction. When they say the second car overtakes the first car, that means it catches up to it. So if car 1 is moving along this way and car 2 starts an hour later and he's faster, so eventually he catches up, when he overtakes car 1, that means that they have traveled the same distance. So our equation is the distance of car 1 equal to the distance of car 2, which is the equation we have right here. Now, all you have to do is solve for t. So it's pretty straightforward. On the right, you have to distribute the 70. So we get 50t equals 70t minus 70. Then I subtracted 70t from both sides so that my t's on the left, which gives me negative 20t equals negative 70. Then divide both sides by negative 20, and you get that t is 3.5 or 3.5 hours. And so remember, let's go back to see what's the question. How long will it take the first car to overtake the second car? So I'm basically trying to find out what is the time of the first car. So once you solve for t, you have answered the question. The first car travels 3.5 hours when the second car overtakes it. So make sure that you're always answering the question. If they had asked how long would it take the second car to catch up, well, you would have had to subtract 1 from 3.5, and you would have said that the second car took 2.5 hours to overtake the first car. So again, always go back and make sure you're answering the question. All right, so here's another one. A plane completes a trip between 2 airports in 3 hours. The return trip between the same 2 airports, 50 miles per hour faster with the help of the wind, takes 2 3/4 hours. How far apart are the 2 airports? All right, so we have the same plane going to an airport and then returning back to the original airport. So if this is airport 1, and this is airport 2, we have the plane going to this airport, but then coming back. So what that means is that the distance is the same, both going to and coming back. Okay, so that's important to keep in mind. But we need to keep track of everything that's going on here. The time is given. It says to the airport takes 3 hours. So that's what you see here. When it comes back from the airport, it only takes 2 3/4. So that's your second column. Now let's figure out the rate. You don't know how fast the plane is traveling, but you know that there's a relationship between the speed going to the airport versus coming back or from the airport. So it says that the return trip, or the from the airport part, is 50 miles per hour faster. So because the wind is pushing it along, so it makes it go faster. So I don't know anything about the speed going to the airport, so I'm going to call that one R. But I know that coming back, it's 50 miles per hour faster. So that's what you see here, R plus 50. All right, so the last column, the D, is the product. So we get 3R, and we get 2 3/4, which is the same as 11/4 times 50 plus R plus 50. So remember, the distance between the 2 airports are the same. So you set those 2 distances equal to each other. 3R equals 11/4 times R plus 50. Then I got rid of the fraction by multiplying both sides by 4. Just makes your computations easier. So the 4's cancel. So we get 12R equals 11 times r plus 50. Then distribute the 11 on the right side. So we get 12r equals 11r plus 1 plus 550. Subtract 11r from both sides, we get that r is 550. And remember, that's in miles per hour. But let's make sure that we're answering the question. The question is, how far apart are the two airports? So I don't want to know what their speeds are, although I do need that information. I really need to compute what is the distance between the two airports. So, which is right here, that's the easiest formula to use. 3r is easier to compute than the one below it. And remember, they are the same. They would give you the same value. So once I know what r is, all I have to do is multiply 3 times r, which gives me 1,650. So the distance between the two airports is 1,650 miles. Okay, so that's a good variation of the types of problems you'll see in the homework. You should give it a try. Good luck.